Today, we will be talking about different types of electrochemical cells. Combination of two or more electrochemical cells is called a battery. These cells are of two types, that is primary cells and secondary cells. Talking about the primary cells, these are batteries that cannot be recharged or reused. They can be used only once. Irreversible reactions occur in them and they are used in portable devices because they produce current immediately. On the other hand, secondary cells are batteries that can be recharged and reused. They can be used more than once after recharging. Reversible reactions occur in them and they are used in automobiles. Examples of primary cells are dry cells and mercury cell, and examples of secondary cells are lead storage cell. Lead cell is an example of a dry cell, and as you can see over here, this has got a cathode which is a graphite rod, and the anode is a zinc container that serves as a anode, and we have electrolyte as a paste of ammonium chloride and zinc chloride. At the cathode, gain of electron takes place, so it's a reduction reaction, and at the anode, oxidation reaction takes place. The cell potential for this cell is around 1.5 volts. This dry cell has a definite life, after which it becomes dead and cannot be recharged. Another disadvantage of this cell is that ammonium chloride, which is used as an electrolyte here, is an acidic salt. And being an acidic salt, it corrodes the zinc container, that is the anode. The second type of a primary cell that we are going to talk about is the small button cell known as the mercury cell. These are very small, so they are used in devices like hearing aids, electronic watches. They exhibit a cell potential of 1.3 volts. Here, the anode is a zinc mercury amalgam. It's an alloy of zinc. Cathode is HgO and carbon, and the electrolyte used here is zinc oxide and potassium hydroxide paste. The reactions that take place here are as shown in this diagram here, below the diagram. At the anode, loss of electron takes place, so it is an oxidation reaction, and at the cathode, reduction reaction takes place. This is the overall reaction. Zinc reacts with HgO to form ZnO plus Hg. Let us now take an example of a secondary cell, a lead storage cell. In the dry cell, in the previous slides, we have seen that the cell gets used up. It cannot be recharged again. But in the secondary cell, the original reactants are regenerated by passing direct current from an external source. That is, it can work as a voltaic cell as well as an electrolytic cell. You must understand, when it is working as a voltaic cell, it supplies electrical energy. That is, it converts chemical energy into electrical energy. And during this process, it gets discharged. We use the word discharged when it gets used up. Once it is discharged, it has to be recharged to be used again. And when it is recharged, it acts as an electrolytic cell. That is, it converts electrical energy into chemical energy. In this cell, if you look at the diagram, you will see that we have alternating anode and cathode plates. Anode here is spongy lead, this one, and the cathode is lead dioxide. So they alternate with each other and they are separated by separator, the yellow line in between, which are made up of insulating material. Each electrode in a battery has many plates connected in parallel, and the plate in each electrode are called as grids. Grids are made of lead metal. For anode, the grid is packed with spongy lead, and for cathode, the grid is packed with lead dioxide. The electrolyte used here is 20% sulfuric acid solution. Since we know that it behaves as a galvanic cell while discharging and as an electrolytic cell while recharging, let us compare the galvanic cell with the electrolytic cell. In case of a galvanic cell, anode is always negative and cathode is positive. In an electrolytic cell, anode is always positive and cathode is negative. In both the cells, oxidation takes place at the anode and reduction takes place at the cathode. You have done this in one of the previous worksheets also. If you look at the reactions that are taking place in a lead storage cell during discharge and during recharge, you will see that during the discharge reactions, oxidation takes place at the anode because there is loss of electrons and lead changes into lead sulfate. At the cathode, reduction takes place as there is gain of electrons and PbO2 changes into PbSO4. If you look at both these reactions, the anode and the cathode reactions, you will see that the products formed in both the reactions is lead sulfate. So white lead sulfate is precipitated at both the electrodes. Due to this deposition, the cell stops working as a voltaic cell and is said to be discharged or dead. Now, since it is a secondary cell, it can be recharged by passing direct current through the storage cell. Direct current reverses the electrode reactions and converts the lead sulfate of the anode to PbO2 and the lead sulfate of the cathode into lead metal. During this process, water is consumed and sulfuric acid is produced. So there is consumption of water in this reaction, formation of sulfuric acid here. So on charging, the electrode material are converted back to their original forms and the cell once again starts generating electricity. So now we know when a storage battery is used to start the engine of an automobile, it acts as a voltaic cell, and when it becomes dead, it needs to be recharged, so it acts as an electrolytic cell. Students, please refer to your book and check up this topic under the chapter electrochemistry. Thank you.